Andrea, for the introduction and for inviting me to be a speaker today. And of course, all of you coming and having interest in water. As Andrea said, it is a very timely discussion, especially with all of the issues we've had the last couple of weeks, especially on our windward sides and on Kauai, as well as just generally this whole winter season. So my job here today, I'm going to introduce kind of the broader picture and policies that are going on relating to water resource management. So my background is a little bit more into like strategic long-range planning. We do this for both the state as well as private sector and the counties. And then we also specialize in what's called green infrastructure. I guess raise your hand if you know what that is, because we will be talking about it today. We got one. Okay, so green infrastructure is more or less defined by utilizing landscapes and natural systems to manage water. But it could also look on bigger picture like the upland forests are a sense of green infrastructure because they bring that brings the rain into our islands and get that water into our groundwater supplies. But we mostly focus in urbanscapes on how we can manage both stormwater and wastewater on site in an integrated way. So I'm going to talk a little bit about that, but I'm going to really just give you a bigger, broad picture, and then the nitty-gritty for your specific historic home needs. Glenn will get into later. Just a show of hands, how many people are actually homeowners in this audience? Well, I mean, okay, maybe I should make that less. I guess who out of the people who came here, how many people are coming with their homeowner's hat on and wants to learn more about? Okay, well, that's still good. And then how many of you are actually historic home owners? Okay, so that's a good portion. Okay, so all of this is all integrated. There's definitely solutions at different scales and both on the home scale and on commercial scale that we'll get into. So just to lean it off, because we are the day after Earth Day and why we care. Generally speaking, if you haven't noticed, we've been putting a bigger and bigger footprint on this planet. And a lot of this footprint is now starting to show its face in consequences in terms of water management and water quality and the way water is impacted in our planet. So just so, as we've been seeing some of the bigger factors of climate change that we need to become more and more aware of, it's not like oil. Water isn't a finite resource. It's really just disappearing from where we're used to finding it, and that's in terms of drought. It's shifting its energy patterns so that we're getting all this rain at once instead of maybe scattered throughout the year. So we're dealing with stronger storms and potentially drier conditions on a global scale. And we saw this a lot last year, just in terms of where the new headlines kept being like the strongest storms that they've seen in the Atlantic. So unfortunately, these larger, bigger storms are predicted to become more of the norm. So also when we think about water, we think of it also how we think about managing it has to do with resiliency. How can we build resiliency into our water infrastructure systems and not have all of our eggs in one basket in terms of reliance on a single supply from board of water or a single end note from a wastewater treatment plant that might be near a coast and susceptible to something like this. Because here in Hawaii, even though it wasn't one of these big massive storms, we did see some consequences from this was 2016 from Darby, but we also saw it just in that crazy rainstorm we had 2 weeks ago, where we get these huge volumes of water creating all kinds of conditions from flooding as well as water quality concerns into our coastal waters. And so even if we're not talking about the Darbys and the hurricanes, what some of the new research is finding that even just there's these storms, you'll hear about the 100-year storm or the 10-year storm. These are basically a 1 in 100 chance or a 1 in 10 chance. But these storms are now happening on a more frequent level. So now this study showed that the 20-year storm in Kailua Kona is now happening, for example, every 3 to 5 years. Another way that we have to think about management of water is also the sea level rise and how we're planning on dealing with that, especially for properties that are near the coast, or when we have discussions with the city, how we can move new master planned communities, maybe where they're going to begin to flood, start thinking about retreating them before they do so. So this is just a picture, for example, of the Alawai Canal, or Alawai Boulevard right next to the Alawai Canal. So this is just a high tide. One of the king tides, and you can actually see the water coming up through the storm drains. So obviously the storm drains are meant to get stormwater out. So in a perfect storm, you could have high tides and a good rainfall event and have pretty significant flooding in the current conditions in Waikiki. Now on the flip side, and going back to that couple of slides, it actually doesn't show the circle here, but you can see at the trends here in the last 30 or so years, we've actually had a decline of about 18% less overall rainfall. So actually, as a statewide, we've been in a drought. And actually, just this last winter, this is the first time we've actually gotten ourselves out of that drought with all this rain. But the reality is the overall trend of rain is decreasing, although we might get all these larger storms dumping at one time. And then thinking about how we want to do water management, we have increasing populations and potentially increasing demands. So how we begin thinking as designers are to manage these systems, we think about it in terms of both scarcity as well as the potential of having too much. So here's just an example of a slide that's actually put out by the Water Commission. And what this indicates is this is our groundwater supplies throughout the state. The areas in red indicate that we're pumping out about the same amount that is able to get back in the ground, whereas the green areas are places where we have more or less adequate supplies. This is called sustainable yield. So obviously in our urban areas, we're basically at that point where we really need to be thinking seriously about encouraging water conservation practices at all levels, from homeowners to new development. So again, this is our infrastructure, how we have it today. Obviously, when it was designed that water was more of a liability rather than a resource. So we pumped all of our wastewater systems to go out generally into the ocean, as well as turned many of our streams to get water out quickly so that we could have houses next to areas that used to flood from the streams. So in many ways, we have trillions of gallons of water being wasted every day. And just to give you context, this went in around the same time as the first computer, the Harvard Mark. So you can just kind of give you the mindset of this technology, because obviously our iPhones and this computer right here is actually not nearly as powerful as our iPhones or any of our laptops. But yet we've come so far today in terms of technology, yet we haven't really done much in terms of our water infrastructure. So that then leads me to kind of what Hawaii started doing about it. So back in 2015, the Hawaii Community Foundation convened a working group. They formed the Freshwater Initiative or Freshwater Initiative Council. And this included both large landowners, included all the boards of water, included the Department of Health. To have a big discussion on what we need to do to have a more secure water supply in the future. And so what they came up with, it was a quantitative study, so it wasn't just fluff. It actually had some real numbers in it. And this actually publication, I believe, if it's not in your list of resources, it can be downloaded from the Hawaii Community Foundation website. And the big thing about it is that we need to have free up another 100 million gallons per day of additional water to support our future populations. So in order to get there, we need to implement conservation practices. They're saying reduce each individual use by at least 25 gallons per person. Double the volume of reuse. So this is mostly targeting recycled water, which I'll get into later, and as well as recharge. This is getting stormwater into the ground versus running off, as you kind of saw in those initial slides where we had Darby and all that water getting into our coastal waters, but rather getting it into our groundwater supplies so it can support our demands out of those supplies. So I'm just going to run through some of these more quickly of kind of like what you guys and how you can participate in some of the Freshwater Initiative actions. So a big one is toilet flushing. So how many people took advantage of the rebate, maybe it was about 10 or 15 years ago, to take your old toilet that was 5+ gallons to at least a 1.28? Okay. So this is a big one. I mean, that alone can save a lot of water for the individual homeowner. I don't know if you know this, but Board of Water Supply is going to be increasing their rates. You would not only see some potential, you'll see some savings from your potable water bill, but also in your sewer bill. So this would just be an easy way to participate and swap out a toilet. And I believe that the Board of Water is actually going to start a rebate program again, so you might even actually be able to get some funding back for these kinds of things. The next one is replacing some of your faucets. So you'll see this in the upper right-hand corner. It's called the EPA Water Sense. How many people have heard about that? Okay, well, this is really a great way to start. Let's say you don't know what kind of faucet or toilet to buy. You can look for the EPA WaterSense label on the actual unit, and they've actually already went ahead and verified that it's a third party, verified via third party that it's a water conservation unit, and that should be on the label if you go buy it at Lowe's or Home Depot. This one's a little bit more for agriculture, but again, smart irrigation systems are now readily available. One of, I'll get to that slide next, but there's a great resource as well by the Landscape Industry Council all about irrigation and how to tighten up your water conservation practices via that. And then, if you really want to get into it and you have yard space, there's the concept of xeriscaping, which here is not really representative in the middle of native Hawaiian plants, but utilizing local plants for your climate. If you're in a really dry area, maybe minimize the plant coverage and incorporate some rock art and other types of design. But really try to have a real low demand landscape is another huge one. So when looking for landscapes in particular, the Board of Water Supply has a great website if you're interested to learn about what native plants might be appropriate for where you live exactly. So this is a clickable interactive website where you can click on which zone you live in, and when you click in there, it'll actually provide you a list of all the native plants that are appropriate for that zone. So if you go to the native plant store, you can look for those specific plants instead of buying native plants that were supposed to be up in Kaneohe in the mountains if you're down on the shore. And again, as I mentioned earlier, this is all these are free to download, and they should be in your resource package. Again, this is a really well thought out, easy to read manual for just simple irrigation measures, including making sure checking for leaks and what types of irrigation that are appropriate for based on the landscapes that you have. So irrigation for grass is going to be different than irrigation for a planted shrub bed, for example, and there's different strategies for that. Jumping in now into the next two categories that go into more of stormwater management as well as wastewater, thinking about wastewater and recycled water. We're talking about recharge in that way, and then we're going to talk about reuse. So when we talk about recharge, that's really coming down to managing stormwater. So before I get too much further, does anyone want to tell me what stormwater is? Rainfall. It's rainfall, but it's not rain, is it? Exactly? No. All right. It can be a trick question because it's really when rain hits a surface is when it becomes stormwater. So rain itself is in the sky, and then once it hits a surface, it becomes stormwater. So once the stormwater falls on the ground and there's like a bunch of hard surfaces like concrete and like roads and et cetera, it'll start gathering more and more water, right, and becomes a larger, I'm going to give you a hint for stormwater runoff. So what is stormwater runoff? Yep. So I mean, essentially, it's when the stormwater like hits that ground. Even if it's not hard surface, let's say it's just a grass. At some point, that soil will get saturated, and then that water will begin running off. So it's basically when it's in excess of what can go into the ground, it will start running off, and that's called runoff. The reason why we care is a multitude of reasons. A lot of times, most people don't realize that stormwater actually can be carrying more pollutants than what we might see in wastewater, for example, and things that are hidden. In terms of things like heavy metals, a lot of our older homes have lead-based paint, the paint chips. When that water runs off, it can carry some of that material with it. Also, if you have gardeners in here, you might use some Roundup occasionally, or you might have some fertilizer. Again, if it's applied in excess, it can run off with that stormwater. And then our cars and other things can carry drop-out oils, sediment, old septic tanks and leach field systems can also, when overly saturated, can discharge. So it can become a real water quality issue downstream, and of course the trash and et cetera. And I think, if anyone was following the news regarding Honolulu, the bay is really impacted by a whole variety of things, and that was caused by that massive amount of stormwater runoff. So how can we minimize stormwater runoff? Well, the whole point is to try to capture stormwater as close to the source as where it's being generated. So let's say if that's your roof, instead of having it go, you have a downspout that might go directly into your driveway or something to get it out quickly where it's going to not be managed. You would create a downspout to be redirected to something like, it could be a catchment tank or it could be something like a rain garden, which I'll get into. So the whole point is to move your yard and other ways from impervious surfaces, which are like your roads, your roofs, your sidewalks, to what's called pervious surfaces, where you can get water into the ground or be stored for some time before being released. So most people, I'm sure, know what rain catchment tanks, but I don't know how many people think they might know what a rain garden is. Sarah knows all the answers. Okay, so a rain garden is basically a shallow depressed garden that's intentionally put in and designed so that you can take water from a hard surface, such as off from your roof, or if it's running off of a hard surface, such as a parking lot or your driveway, and put it into a garden that actually is planted with native plants. It usually has a little bit of an engineered soil mix in it with a little bit of sand and topsoil, so it can hold a little bit more of the stormwater. But it allows the plants and the soils to absorb that water and recharge it into the ground instead of just letting it run off property. So if you're going to have a garden, for example, which a lot of people do like to have nice landscapes, the idea behind green infrastructure and rain gardens is that you make them into something functional as well. So these things can be planted aesthetically with a whole variety of plants. You can mulch them. You can the design part is endless. But the point is they're put in there really as purposefully to manage your stormwater from your property. And these are just kind of some general all over the board types of systems and your checklists for it. Generally speaking, you can't put them on very steep slopes. You want them to be relatively flat when you put them in. In this situation, you have the upper left is actually more of a commercial one on a city street where they did some curb cuts and made this strip of a garden before it entered the storm sewer. But they're happening at schools and in the backyard of other facilities, and they sometimes become community events as well. The other option, again, is looking at rain catchment. These can happen at a variety of scales, and Glenn is going to probably get into some more that are a little bit more aesthetic. But the whole idea with rain catchment is that you're capturing a certain stormwater volume, and the reason why that's good is because instead of letting all that volume continue to run off, and which if everyone doesn't capture or recharge stormwater, it's just going to keep collectively moving downhill with all the pervious pavement and pervious surfaces, and that's when we get all that flooding. So what catchment does is it stores a certain volume, and then you can use it when it's drier. But the main purpose is for protecting flooding conditions as well downstream, because you're storing at least your volume of rainwater. And of course, it can have a variety of uses, including watering your garden. That's actually my niece up in Canada, and they put one in at their school. This doesn't necessarily apply to homeowners per se, but just to give you a perspective of all the different types of practices that are going on in terms of implementing green infrastructure. I'm sure more and more you guys are walking by some of these systems and you don't even realize what they're necessarily doing. But there's everything from tree box planters to these rain gardens to green roofs, as well as permeable pavers. Does everyone know what a permeable paver is? Generally speaking, we have those, you have pervious asphalt or you have pervious concrete, impervious, you have your regular concrete or regular asphalt. Nowadays, you can actually get concrete poured that is pervious, so some water will actually go through it. You have to specify that with whoever you're going to order your concrete from. You can also do this via pavers. There's a variety of pavers out there that you can implement. So if you have your driveways or you have patios that are just now currently concrete, you can actually make these into pervious pavers and allow for that stormwater to get into the ground. And of course, if you're going to start planning out any kind of rainwater harvesting or rainwater catchment, this is a really wonderful resource. This was developed by the Geography Department at UH Manoa. It's called the Rainfall Atlas of Hawaii. So you go into their interactive map. You can click anywhere in the state, And you can see where I kind of dropped my X, and then it automatically produces your monthly rainfall volumes. And this is based off the last 70 years of rainfall data around the state. So if you just want to know how much rain am I expecting to get relatively at my house, you can click on this. And for those who are really savvy and want to get into the math, you can go into Google Earth and find your roof area. Let's say you want to figure out how much water is coming off my roof. You could zoom into Google Earth, measure out with they have a measurement tool in there, measure out your roof, and then just calculate essentially your roof area, which will be in feet. And then you're going to have to convert your inches to feet, and then you can convert cubic feet to gallons, and it'll give you your total annual gallons. I'm happy to walk through afterwards if anyone wants to go through that exercise. But the point is it's really important to know how much rainwater you might be getting or expecting. In terms of reuse, probably the easiest things for homeowners to do is utilize we're currently in the 2006 Uniform Plumbing Codes everywhere except for the Big Island. Unfortunately, they're not quite yet there, but allows for folks to capture their gray water on site, and you can use it, but it has to be subsurface. So that means if you disconnect your washing machine and you want to run that water out into your garden, you just need to make sure that that water flows underneath the ground in a perforated pipe or in a way that you're not going to see ponding on your surface. But you could do this really for hand washing sinks, showers, and washing machines. And gray water is about 50% or more of your total water use. So it can be quite a substantial volume. And you would have a lot of cost savings because that would be off of your you would basically save water from, because you actually still would get charged from your potable end. Eventually they'll figure this one out, but on the catchment side, I was just going to say you would save on your bill because the way that your bill is structured, your total water use is taken by what's coming into your property, and then they discount for irrigation. So if you reduce your total volume by using catchment water, or if you were going to use gray water for irrigation watering, that would be that much less off your bill, and then that much less you would get charged. This is just some examples of outdoor showers where this has been done. I don't know how many folks have outdoor showers, but you can easily then divert the water into these garden spaces. Not so much for homeowners, or existing homeowners, but just to kind of make you aware of what's happening. There is a big push to get treatment plants to produce what's called recycled water, R1 water. It's actually very clean water, and it can be used for a variety of end uses. For newer buildings, we might begin seeing this water being used for flushing toilets, for example, makeup water for some of the cooling towers, basically trying to fill in a lot of the areas that don't require fresh drinking water. And this is kind of the future and the vision for some of the new master plan communities we're working on, but the idea of these, what's called eco-blocks, to think about multiple mixed residence and commercial, how we can capture water, utilize the water that's on site, and minimize the output to the sewer, as well as the demand from the potable supplies. Again, this is just sort of a roadmap to explain this, but generally speaking, all the purple things are end uses that don't necessarily require our fresh Board of Water Supply potable water. You can fill that demand with treated stormwater, wastewater, and condensate recovery. So I'm just going to run through a couple examples because I think it helps to kind of picture up like what these things might look like. This here is the Public Utilities Commission building in San Francisco. These planter boxes are actually what's called a constructed wetland. They're actually a wastewater treatment plant, if you can believe it. So it runs along the city sidewalk, it treats the wastewater from the building, and it uses that water back inside the building for flushing toilets. It has a 40,000 gallon cistern at the basement of the building, and that's also used for makeup water back inside the building. So this, when it's generally in the wet season, this building is about 40% self-sufficient in terms of its water. On a different scale, this one is actually one of these kind of more eco-block scenarios. This is in Portland. It's a mixed residential, commercial, relatively new building. We have about 657 residents. And so again, on here, they have this middle picture is showing, again, another constructed wetland on-site wastewater treatment being using that R1 water to be used back inside for flushing toilets. They have a large cistern, but before it even gets to the cistern, they have like a green roof scenario where they capture the water and filter it through the vegetation on the roof that you're seeing there. And then it goes down through some water features around the property before it actually gets stored. And they have a variety of other eco-friendly things going on as well, but this is another example of on-site water management. And even on an even grander level, this is Emory University in Atlanta. And instead of them actually just treating their own wastewater, they actually pull wastewater from the city sewer and treat that to recycled water quality to meet a lot of the demands on the university. And as well as they do a very large amount of stormwater capture. They got here about 800,000 gallons per year that they offset from their potable water demands. Their wastewater is about 400,000 gallons per day that they treat on site and recycle. And so just importantly, talking about resiliency, so a lot of what this also kind of, I want to try to drive home, is whatever scale you can do it and operate it on, if something were to happen in terms of something to our water supply or to our sewers, you would have some ability to operate. So a lot of times targeting certain areas where they might be shelters to implement these kind of things could be strategic. And as a homeowner, knowing that you might have a backup cistern just in case something happened with our water supply is always good to think about. So the real thing that we're going to get through is that we need to get through it in order for all this to happen locally, which seems to be happening sometime, we hope, this year, is that we're going to be updating the plumbing codes, or the city and counties will be updating the plumbing codes so that we can actually begin looking at plumbing things back inside the building. So with that, I'm going to leave you with questions.